My name is Gavin Ryan, and I'm from Ireland. I moved over here to America in 2004. Postdoc at CSU for 8 years, and then I just saw motorized microscopy certainly change our research. We're able to think of a lot more projects because we could get a lot more work done within a 1 year period. And more work done means more data. Generally, hopefully that means more papers, and hopefully that means more grants. And that's basically what we do at the moment. We try and improve people's productivity and flow rate. So right now, today is pretty much the best microscope that Olympus has to upgrade your scanning capacity, your speed capacity, your volume acquisition capacity. So what I'm going to do is introduce the slide scanner, show you what Olympus have done, what type of technology they've put into this thing to make your exposure times low, your resolution high, and your scanning speed very, very fast as well. And then the idea is that you can shove in a whole project. You can shove in maybe 80 slides and then batch scan that, and also batch analyze using artificial intelligence. And that way, the idea is that people are then used more efficiently, which is subjective, rational thinking, scientific thinking of looking at the data and saying, interpreting what does that data mean? Is it positive? Is it negative, etc.? And that's really where humans should be. Instead of just sitting in a microscope room all day long, taking images, if you got a robotic microscope, it can do it for you, leaving you free to do more work. Go back to the lab, set up the next experiment, or just go back to the office and interpret results, or write that paper, hopefully, which is the ultimate goal. So let me proceed with the talk. So the VS200, this is generation number 6. Olympus have been slide scanning for 15 years. And we're really beginning to see quite a maturity in this scanner, where it's very, very fast, great resolution, great image quality, and great software as well. So it comes in 2 flavors. There's the base model here, which is, and hopefully you can see my mouse circling. I've put on the laser pointer, but we have a 6-slide system here. And then you can upgrade and add this robotic loader system on the right-hand side. So the difference between these 2 models is having a 6-slide capacity on the left or a 210-slide capacity on the right. And that way you can shove in literally an entire project, or get on a project done in 2 or 3 batches. So it does do bright field fluorescence as well, but these are all modules that you can add and build over time as your needs progress. So, oh, sorry, I forgot that slide number 2 has a larger image. So that just pretty much shows what I was speaking about, the 6-slide system or the 210-slide system. This module can be added on. It's actually an American company that adds the robotic loader. So it's done over a 2-day period. So you're down for about a day and a half, 2 days, and then you've just increased your capacity from 6 slides to 210. It does have different software modules as well. So it's a complete system. So you do have an offline version of the software, which is called desktop. You've got a VSI conversion tool. So the native file format is VSI, it's virtual slide image, but that can be converted to TIFF, big TIFF, JPEGs, PNGs, and a whole plethora of other file formats. So whether you're using Halo software for analysis, maybe using Visiofarm or other software modalities, these file formats can be converted to commonly used file formats, and therefore you can use other software platforms as well. And one of the software modules is called Detect. That's more of a pattern-based recognition software, more like a Fiji or ImageJ, something like that, with all different filters, size, shape, sphericity, etc., etc. And it was brought out artificial intelligence about 1.5 years ago, and that's very, very easy to use. I'm going to show you a little bit about that later on. And the AI, it's a neural network instead of machine learning, so it's the more advanced AI out of the common 2 flavors of AI that are in the market. There's 3D deconvolution, and that's actually a constrained iterative, fully quantitative algorithm. So if you do want to do a ratiometric study and compare intensities in a project over time, this 3D deconvolution algorithm will retain all the quantitative data. There's not many decon algorithms that do, but this is one of them that definitely does. There's a module called NetImage Server, which actually, it's a file sharing platform. So you can actually share these images just like logging into Netflix on your phone. So you can be in a coffee shop and one of your collaborators or maybe a student or a PI can give you a call and say, hey, we just scanned an image. Can you take a quick look? Because We would like to bring this down to the laser scanner confocal and take a deeper look, but we want to make sure that it's actually positive. What do you think? And you can pull up your phone, log into the internet, and stream that image live on your phone. A little bit funny on your phone because your screen is always small, but an iPad or a tablet would be a lot more suitable. And you can use a Linux computer, a Mac, a PC, anything that has the internet, you can log right in and have this. And then we have free viewing softwares as well. So if you're collaborating with people in New York, for example, you can share these images over the internet, and they can have this free software called Olivia, which can open up all the images for them as well. So you're not going to be left exclusive to something that you have to continue to purchase. Olympus does have free viewing software as well. So what have they done to improve? The idea of improving a slide scanner, you want better resolution, you want faster scanning. That's and a higher capacity. They're generally the three main components. So compared to the predecessor was the VS120. This new model is the VS200. They've added a new beam splitter. It's a new tube lens, and the tube lens is wider and it's got a higher NA. So it's better at gathering light. It means your images are brighter, and that means you can turn your exposure down, and a shorter exposure time leads to faster scanning. They've also added in the new X-line objectives. So most of the big companies like Zeiss, Nikon, Olympus, they've brought out a new generation of objectives roughly about every 10 years. And Olympus brought out their X-line of objectives 2 years ago, and we're seeing a very, very high degree of maturity within optics. They're I wouldn't say they're close to being perfect, but they kind of are. Let me show you a slide later on that shows you some of the metrics of the X-line objectives, and it shows some of the improvements of the predecessor. So the new X-line, some of the objectives got a higher NA, like the new 20X has got an NA of 0.8 instead of 0.75. The flatness, and there's a slide coming up that shows the flatness improvement. They've improved the flatness fourfold. So edge to edge is literally pin sharp. And then the NA is improved slightly. But the other improvement is chromatic correction. So you've got your far reds, your red, your green and blues. And sometimes they don't line up in the exact same focal plane. They may be a few hundred nanometers slightly off. Normally you can adjust that with software. But with this new X line of objectives, going from, say, DAPI or maybe the 400 UV range up to the far red, like 750, 800, they align almost exactly on the exact same focal plane. So now you don't have to correct for this within software later on or move the Z when you're scanning. It's already corrected optically within the objective lens. So the scanner is actually, it's a 6-position nose piece. So you can add in 6 different objective lenses. Normally we go from 2x to 60x. There's not really need for the 100, but if you do need a 100x objective lens, you can add that in there. And because it's a 6-position nose piece, it accommodates a lot of the 250 different objective lenses that Olympus have to offer. But one of the oil objectives is a silicon oil. So if you're going to do a very, very thick sample, say for example you want to do cleared brain, and it's 50 micron thick slices, and you want to take big Z stacks of big slices that are cleared, well, that 60x silicon objective is going to be ideal for that. The silicon oil matches the refractive index better than normal microscope oil. And therefore, as you go deeper, because you don't really have a big change in refractive index, you don't have that much distortion where the light tries to come back out of a thick sample and gets distorted. So you normally lose a little bit of point spread function, you use intensity and resolution, but with the silicon objectives, that changes. Your light go much, much deeper without losing resolution or brightness. So they are great objectives. So if you do have a thick project, when we bring the microscope down for a demonstration, and so far the date is November 15th, bring along, let me know if you're going to bring thick samples, and I can bring the silicon objectives, and we can see how far this system can go for you. The silicon objectives, you've got 40x, 60x, and 100x. The scanning, if you do have any motorized microscopes that are scanning at the moment, if you notice that there's some tiles or some areas are a little bit out of focus, where the focusing wasn't that accurate, it happens the odd time. But if you've ever experienced that, the new scanner has improved the Z accuracy into plus or minus 100 nanometers. So normally if you've got a 5 micron thick tissue, plus minus 100 nanometers doesn't quite get noticed. So the Z accuracy is to a point now where it's extremely nice. It's extremely reliable. So we just don't have focus issues. So this slide really is for all the pathologists who are watching, or people who are doing bright field images and really want to recreate what you see there in the microscope as what you see in the monitor, that those two match up exactly. So halogens and mercury bulbs are generally a thing of the past now. Most companies are going LED. They're just a lot more stable. So when Olympus looked for some commercially available white light LEDs to replace the halogen lamp for bright field imaging, they noticed that it didn't match up the halogen. The halogen here is in the middle, and it's a halogen with a daylight filter, so it's a nice clean white. So some of the commercially available LEDs didn't quite match up. The color temperature was just different. So Olympus made their own, and their white light LED very well matches the halogen lamp with a daylight filter. So the two traces can be seen here. The one in pink is the halogen transmission curve going from UV up to far red, and then what's in yellow is the white light LED from Olympus. And then in blue here you can see this just large variation within color temperatures as you go across the spectrum range. What's nice about the LED is as you turn down the power, the temperature of the white light doesn't change. So it's a clean white light. The only thing that changes is intensity. If you've noticed, if you change the power on a halogen lamp or more entry level or more cost effective LEDs, you may see the color change from blues to maybe yellows or slightly reds. That does not happen with the Olympus LED. It always stays this nice clean white. And likewise with to ensure what you see down the microscope eyepieces best match what you see in the monitor, Olympus have got in a new camera. It's made by a company called IDS, and it provides ICC color profiles, which is the International Color Consortium. So therefore, you don't have these funny images where you scan an image and you look at it going, the gamma looks a little funny, or maybe the brightness is off, or maybe the contrast is off. Maybe it's artificial and it pops too much. It may look pleasing to the eye, but when you zoom in, you may look at the resolutions, you lose a little bit of resolution, or maybe vice versa. You've got nice resolution, but the contrast is funny, and you can't just distinguish the different layers within your tissue, or maybe the cell border. The contrast is lost, and you just lose that. What you see down the microscope is what you see in the monitor. So the VS200, the bright field images, they're reproduced they're quite nice. They're very pleasing to the eye, but let me not be a judge of that. I'll leave that up to you guys during the demonstration. Please bring your H&E images or your color images. If you've got immunohistochemistry, we can definitely scan these, and let me know. We always get feedback from customers to see what you think of the image quality. Here is the slide I want to show you about the flatness of the field of view for the X-apo objective. So traditionally, if you go from the center field of view of an objective lens out towards the edge, it is common to have a little bit of loss in intensity at the edges. And with the previous generation of the S-apo, which is the top of the line apo-corrected objective lenses from Olympus, there was an 8% drop off. So if you get to the very, very edge here, this is about an 8% drop off in intensity. But the new X-apo objective lenses, which is shown here in blue, that's only a 2% drop off. So these are raw images. And when you see the difference between the X-apo objectives on the VS200 compared to the previous model, the VS120 model, with the S-apo objective lenses, we barely need a shading correction, which is it makes our job a lot easier, of course, when there's no tiled patterns. If you ever see a quilted tile or pattern in previous scans that you may have seen before, that's pretty much a thing of the past at the moment. It's quite nice. And likewise, if you go into a H&E and go into the 20x objective lens, if you go from the center of the field of view out towards the edge, and you have this edge of the image here that's blown up, you see that the previous generation, you can see that these nuclei here in the top left-hand corner, it's getting a little bit soft. But if you look at the X-apo, and look at the same image, the corner of the image where it should be a little bit less intense, and maybe you lose a little bit of focus, you can see that these two nuclei, you can still see the nucleoli, you can see the nucleus border. It's quite a nice, the resolution going from the edge to the center, there's no difference. As I said, they're pin sharp edge to edge, which really makes these lenses they're just great to work with. They just have less issues. It's a maturity in lenses and lens technology, which is quite nice. Likewise, that carries over to fluorescence. You don't have a loss in intensity. You don't have a loss in resolution. Nothing's out of focus. So when it comes to accurately measuring the intensity and trying to do a ratiometric study from the edge of the field of view to the center, there's very few corrections left to do at this stage. Pardon me. So the XAPO objectives, they go from 100x oil down to 4x. And one of the new upgrades of the system is a new camera. So the camera, the pixel size now is 3.45 microns. So if we get the XAPO objectives and the new camera, and then compare the older scan of the VS120 to the new scanner, let's look at one objective lens. Let's look at the XAPO 20x. The resolution is 0.274 microns per pixel, whereas the previous version was 0.345. That's about a 25% increase in resolution, which is a fairly big increase. And if you have a 5 or 10% increase in resolution, that's nice. But going up to 25% in today's day and age with quite mature optics, that is a nice increase in Olympus, or in image quality and resolution. So one of the features that the scanner has, it's called an EFI. It's equivalent of a max projection within fluorescence, but this is an EFI. It stands for extended focal imaging. So with this example here up top, you can see that we're focused down the bottom of the image. So this part of the image here is attached to the glass slide, but there's some depth to this image. Maybe some parts have kind of floated off, or maybe they've absorbed too much liquid, or maybe it was cut incorrectly, where there is some depth here. So clearly in one image in a single plane, we cannot acquire everything at the same time. Some parts of this are just out of the planar volume of focusing and out of the focal depth of the objective lens. So what the scanner can do is it can take multiple Z stacks, but flatten it as it scans. So it'll go to one field of view, take a Z stack, flatten, and move to the next field of view. And it does this on the fly because computers are fast enough at the moment. So the image down the bottom, it's an EFI image. This would have been comprised of multiple Z planes. I don't know what this image is. It could have been anywhere from 7 to maybe 31 Z planes, all flattened down. And it does a fantastic job. So right now, I'm actually the Fred Hutch Cancer Research Center up in Seattle. And we've been doing EFI scans all week long, and they've quite really enjoyed being able to shove in some of these thicker samples, particularly bone, because I can get quite spongy and quite lift off the slide. And it can absorb water in different intensities and increase in depth at different parts of the slide. So they can be a little bit problematic to scan. So we've been doing EFI a lot this week, and that's gone down really, really well. Here's another example of EFI where you've got a fly, you have multiple parts of the fly, little hairs, and we scan this again with an EFI, multiple Z stacks flattened down. Now what you can do is you can actually acquire all the Z stacks but not flatten. So you can still have your data file with up to 31 Z planes. And then later on with the software, you just roll the mouse wheel and that focuses up and down through the 31 Z planes for you. So you can drive around with the mouse and then focus. So it really is a virtual microscope. And that way, so some people at Colorado State University are trying to teach students to find these little oocytes, these floating oocytes in 150 microns of fluid. And they're trying to teach the students who just haven't had any microscopy experience that if you don't see anything in what you're looking at, focus up and down. Because if something is very far out of the plane of focus, it can be so blurred and so convolved that you're not going to notice it. So they don't want the flattened image. They want all the Z planes to teach the students to focus up and down later. And of course, digitally, they're focus up and down using a slider on their iPad or on their touch screen or on their phone or whatever. So they're learning remotely, and that's one of the benefits about this system is it can actually generate revenue as well on the educational aspect. So CSU have got that net image server software I mentioned earlier on. So they have students as far as Alaska logging into their histology courses, their pathology courses, and now they're all sharing the same image. So when it comes to examinations as well, they're not just getting a slide that they may turn around later on after the exam and say, oh, well, I didn't do too well on the exam because the example I have on my slide wasn't as clear as that this other person got a better slide. Maybe it was cut different in the sample, and it's a better representation of that pathology. Now the students are looking at the exact same slides. They're all digital. They can focus up and down. Plus, you can share images. You can get images in from like Australia, from the Middle East, from Ireland, anywhere at all. And now students are getting exposed to multiple different types of pathology or examples of this disease or histology or whatever you're trying to show them from any parts around the world. So this kind of digital sharing of images is really exploding. And you can do all that with this virtual software and this sharing platform. And by the way, the sharing platform, the NIS, the Net Image Server, it's not just images. You can add in a Word document. So if you have a whole project written up and typed up, and even an Excel spreadsheet that has your data tabularized, then you can actually add this all together, upload it into a folder, and share that with collaborators to have direct access anywhere on this planet. So what is next? Oh yeah, so this is just a quick video. You're going to see things moving in these videos. So when we move into fluorescence, you can EFI a fluorescent image, but the max projection usually comes out much better. You can have deconvolution. There's two different types of deconvolution. There's a free one that comes with the system. And if you want to go to the next level, there is the algorithm that is quantitative that I mentioned earlier on, and that's available for purchase as an option later on. So you do have deconvolution, and then you have your Z stacks where you can scroll up and down and try and find your image. So that was just taken from, I believe, a little worm. I don't know what type of, it just says worms. I don't know the scientific name. They're not C. elegans, but it looks like something else here. Okay, so flexibility. How flexible is the system? So the automatic loader takes these trays. The trays are about that big. They're nice metal trays. And there's actually 4 different trays. We're only showing you 3 here. But the standard tray takes 6 microscope slides. You can put in 35 trays, so 6 by 35 is 210 slides. We were scanning some of these double wide slides here at Fred Hutch, where some people have like human test days. They have maybe larger samples where you can get a whole project on. Maybe you can get like 30 brain sections in one big double wide slide. It's 2 inches wide, and that way it stains the same, right? Same antibody treatment, same washing, everything was treated the same way. And that way you cut down on your inter-slide variability. That way you're staining everything in the same way. It was treated the exact same. And we've had a couple of people make very, very positive comments saying, well, we're not using it now, but for a ratiometric study, that would be nice to use these double wide slides. It can scan 105 of these double wide slides, or it can scan one of these slides, which is a 4-inch wide by 3-inch. These are for like primate brains, maybe horse femurs, or just larger tissue sections in general. Pardon me. So when you put in these trays, in the top left-hand corner here, you may not see it on your screen, but there's a little RFID, little radio frequency identification tab. So when you put in the tray, the scanner goes, oh, you've changed tray, and I know what tray it is. I've already automatically detected it. So it's one less thing for the user to do. You don't have to click. And also when you have these 6-slide trays or these 2-inch wide slide trays, when you put in the slide, a little slider moves up, and there's a little sensor on the back of the tray that moves up as well. So when you shove in the tray into the scanner, it knows if there's a slide there or if it's an empty position. You don't have to tell it, hey, this is empty, here's a slide, don't scan here, scan here. So it's quite automated where if you're just tired, you want to go home, you can just put these things in, hit scan, and start a whole batch. And we've counted the scans here. You can start a batch scan in 3 clicks. That's once your protocol is saved. Setting up a protocol is easy. It's like a normal microscope. You select your objective lens. You select what filters you want. Maybe you want Dabby, Fitzy, Tritzy. You set your exposure times with your live window. You just hit plus, negative. You can eyeball it, or you can use the histogram, or you can use your high-low or your saturation indicator. So you set your exposure times. You click and drag a line where to scan. So you scan this area of tissue. It actually has an edge detection algorithm as well. So if you're going to go fully automatic, you can put in like 80 slides, hit batch scan, select your protocol, and hit start. It's going to do an overview map using a low power objective lens like a 2x or 4x. And any tissue that's there is an edge detection algorithm that will recognize your tissue and just scan your tissue alone instead of scanning the whole slide. And that's how automatic the system is at the moment. 3 clicks will scan everything. There is, let's see. Oh yes, there's an automatic oiler. Linda's tried to bring this out before, but the automatic oiler, it would produce a bubble, something like 1 in every 10,000 images. And I just didn't like that. It just said, look, it's a threat. It's not reliable. Yes, it works for the most part, but we want it to work all the time. So the automatic oiler got delayed by a whole generation. It took a couple of years to come out, but they have this little dropper at the moment, and there's a beam. So the oil drop goes through the beam. So the pump will just go until a drop forms, and it'll keep moving until that oil breaks the beam, then it stops. Rather than just relying on trying to push out a certain volume, because the oil may not drop. But there's a little video here which I'll play. So it's good. You can see the oil at the top middle of the screen. It's good, and there's a little beam detector underneath. So it drops the oil, and then the objective is moved into it slowly, and that speed has been worked out so it doesn't trap any air bubbles. And then it starts scanning. So you can actually oil scan an entire project at 40x, 60x, 100x. You can do normal microscope oil or silicone oil, and you can mix and match protocols. So say, for example, you've got 25 slides. You can do the first 3 slides at 10x bright field. You can do the next 10 slides at maybe 40x fluorescent imaging with Z-stacks, and maybe the last remaining slides at 60x oil with no Z-stacks. So you can mix and match and add in any project you want. You just click, and it's a very, very simple setup. But the automatic oiler is really cool. And one of the newer X-Apo objective lenses, it's a 40x oil. It's still a relatively big field of view, but it's got an incredibly high NA of 1.4. And years ago, we'd only see an NA of 1.4 on like the 60x oil or even 100x oil. So it's that's a really, really cool objective lens. So high-speed scanning, relatively high speed, very, very high resolution as well, and all automatic and oil. Okay, let's get this slide. Oh, so different options. So I mentioned earlier on, this is all a la carte. You can build up this system and to make it go as fast as you want. You can have different light sources. So more and more people have asked for IR. Maybe Opal dies into the 790, Alexa Floor 800s, size 7 at 750, Alexa 4 750. So a bunch of different dyes that are moving to the front of reds. And the advantage about that is that your tissue autofluorescence is almost non-existent when you go to about 650, 700s, and it goes down even lower in the 700 range. So Olympus have partnered with multiple third-party companies, but one of them is a company called Excite. They've been making absolutely fantastic light sources. So we can put a white light LED on, a white light LED with filter wheels. You can put a turbo, which is a 6 LED system, and a Pinkel cube, so no moving parts. And you've got very, very rapid channel switching. The channel switching is about, it's less than 1 millisecond. So much, much faster than a filter wheel. And then lastly, there's a new Excite Novum. The Novum came out about 1.5 years ago, right as COVID is really beginning to kick in. But that's got infrared up to 800. So now you've got channels from DAPI up to 800. So you've got this very, very large spectrum of wavelengths where you can mix and match. Now, if you get filter wheels, of course, you can mix and match your filter wheels. So you can excite with, say, UV, but image in red and skip blue and green. That way you've got a giant Stoke shift. And concurrently, if you're going to, these dyes are not out yet, but I'm hearing about them where they've got a reverse Stoke shift. So you excite them at red and they emit green. They emit photons of a higher energy. How do they get the energy? They absorb ambient temperature. So the surrounding temperature in the slide, just around the floor for, actually cools down to a tiny level. It's kind of cool. But your tissue autofluorescence doesn't go backwards. If you excite tissue at red, it's going to come out far red. It doesn't go back down to green. So your signal to noise ratio is almost perfect. You have a jet black background and just your fluorophores that have got a reverse Stoke shift. By the way, if you see them commercially, or you're making them yourself, please let me know. I'm getting more and more requests from customers, and I just haven't seen these commercially, but I do know they exist in research, and I can't wait for them to come out. So if you have filter wheels, you can get a dichroic with reverse, instead of you just get the reverse profile. So it allows a reverse Stokes shift, so you can excite with a longer wavelength and image with a lower wavelength. So kind of cool stuff. Can't wait for those guys. Yes. So back to the talk. Got sidetracked there. UV up to far red. Huge, tremendous range of wavelengths. The VS200 can go up to, I believe, 12 channels. So if you want to fill this up and get the whole shebang, you get mirror cubes and filter wheels. You can go up to 12 different channels. So a lot of people will get the Penta, the Dappy Fitzy, Tritzy, Sci-5, Sci-7, and then jam in there CFP, YFP, and Cherry. And over those 8, you're generally covered. You really are covered with a tremendous length of, tremendous range of wavelengths. Okay, this slide it's a little table of mixing and matching, whether you're going to go with LEDs, fast switching LEDs, or filter wheels, etc., etc. So as I play this video down here, yes, you can see here in the bottom left-hand corner the filter wheels changing quite fast. So you have very rapid and high speed. So moving on from high-speed fluorescent imaging to more research-grade platform. I mean, it's easy to shove in 100 slides, hit batch, scan, and hit go. That's super simple. But what happens if you want to get something into go to the next level of complexity, where you're like, well, I've got a picker series red stain, so I want to do my overview in bright field just to find it, but I don't want to scan in polarized light. So the scanner can do fluorescence, bright field, phase contrast, it can do DIC, and it can do polarized light. So and it actually does dark field as well. So it does a tremendous amount of different imaging modalities. So here, if you look at the top right-hand corner, this brain section, the overview was scanned in dark field, but then the detail scan, the high-resolution scan, was in fluorescence. So why would you do that? Well, you get a lot of information about the histology with dark field. Plus, dark field is incredibly gentle. You're not photo bleaching anything, and therefore you can overlay the fluorescent image on top of your dark field image, and therefore you kind of get a histological background, and then your fluorescence on top of that as well. So that's cool to do. That's a very, very fun to do. Phase contrast. This image is actually a larger image on the next slide, so I'll skip this one. But you can do polarized light. Here's a picker series red, so where someone did polarized light on one half, and the other half is bright field. They can just see a red image. And these are layers. So you can layer up your H&E over your maybe polarized light. And you just click the layer in the software, so the layer disappears and appears, disappears and appears. So you can overlay these two quite quickly and see if that sample is a positive or a negative. Oh, this is what I was talking about earlier on. This is kind of a batch mode. It just shows you the flexibility of the system. So here we've done a batch of 12 slides, all bright field up here, H&Es. A couple of monochrome images down here. This could have been dark field, I'm not too sure. And then over here, you've got fluorescence images as well. So this just shows that you don't have to do a whole batch of 200 slides of just H&E or just fluorescence. You can mix and match these, what we call observation methods, and say, this one's a H&E, this one's bright field, this one's polarized light, this one's fluorescence. And that way, if you're in a core, and you do have multiple users coming down at 9 o'clock in the morning, you can accommodate everybody. If they have 20 slides each and there's 5 people, it's 100 slides. You don't have to say to them, okay, user number 1, give it a scan yours. It'll be done in half an hour. User number 2, come back in half an hour. You don't have to do that. It's very, very convenient, very, very flexible. So you can get everybody in one room, shove all the slides in, get everybody to choose their protocols in one sitting, and they all leave. And they all come back at the end of the day, and all their slides are done. So we've had great feedback from core directors saying, you know what, the flexibility of the system is pretty cool. And on that note, there's 2 more reasons why it's flexible. So number 1, maybe it's in the middle of a large batch, a large scan. Maybe it's going to take 5 hours. And someone runs in with this one slide saying, look, I really need to scan this now. I don't want to wait. Well, there's a little button that says priority scan. It's actually down the bottom. I can see it here. That actually says priority scan in the world's smallest font. But you can do priority scan. It pauses that batch, opens the door, gives you a tray, and it says put your slide in slide position number 1. You can put in position number 1, scan it, and say I'm done. It'll say, okay, put your slide back into position number 1, the one that was disturbed. You put it back in, you hit resume, and I'm not making this up. It goes back to exactly where it was, even in oil scanning. It's cool. It really is cool. So that's number 1. Pardon me. And number 2, I get this a lot from technicians. Technicians are like, listen, I've got children. I got to go at 4 o'clock. I got to go pick them up. But I'm under pressure for my PI to get all this project scan. It's got to be done by Friday for this grant proposal or whatever deadline it is. So I don't want to come back at like 8 p.m. tonight and put in more slides. What can you do? So there's, you can actually, say you're doing 35 trays, 210 slides, but it's scanned the top 20. It's 4 o'clock, you want to go home. You can open the door, take out the top 20 trays, fill them in with new slides, put them back in and hit resume. And the system, because it's all sensors, it knows that you've changed the top 20 slides. So when it finishes the last 15 trays, it goes back to the top 20 and continues. So you kind of, quote unquote, top up the system before you go home for the weekend or go home for the night. And also, if you are under time pressure, the system will email you when it's done. So if you're in the lab and you're busy and the scanner's maybe next door, your phone will notify you, run next door, start the next scan. And that way we've, Olympus have added in a couple of these different options to just improve the workflow so you can get as many scans done as possible and be more time efficient. Here's the example of dark field with fluorescence in GFP, TRITSI, and then a DAPI overlay. So that's where you can kind of get a mix and match of histology and fluorescence. And that's fun to use. That's always a fun scan. Multiplexing. So if anybody's doing multiplexing where you image your slide, say with 6 antibodies, you image it, remove the cover slip, strip the sample, add on 5 more antibodies, cover slip, back to the scanner. You bring up your old scan and you say add to scan. So now your 5 new antibodies get added on to your 5 old antibodies. And now you've got 10 different channels and 10 different antibodies. And a lot of people are doing that for cancer to bring up different biomarkers and different protein expression to see what type of flavor cancer is going on, what stage it's in, what's the physiological level, to help analyze and categorize these pathologies to a higher degree. You can do that up to 64 channels in one image, and you can detect 64 different options. So I can talk about multiplexing another day, but that is kind of cool. Here are the different file formats: OME, TIFF, open microscopy format, big TIFF, JPEG 2000 TIFF, JPEG and PNG. So you can work with multiple softwares: Indica Labs, Visiopharm, Imaris, Fiji, etc., etc. Okay, speed up your workflow. This is for people who are doing scanning. These time metrics, the average loading time is 9 seconds, which is quite nice. We're beginning to run out of time, so I'm going to speed up here. Here's scanning time. So a 15 by 15 millimeter piece of tissue. It's a lot faster these days. So for bright field, it's about 105 seconds using a 20x objective. So that's a minute and a half, roughly a minute and a half for a 15 by 15, which is about the size of your thumbnail, roughly. Going to fluorescence, 15 by 15, and did they put in the details? Oh, one channel. So one channel, 2 minutes. Total with the overview map and everything, focusing and everything, 3 minutes, 13 seconds per slide at 20x. So that's a rough idea for times when people ask the question, how long does a scan take? Of course, 40x is longer, 20x is much faster. Oh yeah, here's a video of the robotic loader. So this is the 6-slide system. Right. So if you get a 6-slide system, this video shows you just removing and inserting the tray. It's very, very simple. Olympus went to a tray system because it's easy for the robotic loader to grab a tray. Plus, it's only one loading. You get 6 slides. It's much faster. The previous model had slide by slide, and it was slower. But this one shows you this video here shows you tray, or it's like a robotic loader picking up a tray and putting a tray into the system. So it'll scan the slide label for you with an overhead lighting, and then go back in a higher resolution and scan the rest of the slide. By the way, it does barcodes as well. So if you guys are interested in barcode system, it's got an automatic built-in barcode scanner. And because the trays are huge, about this big, the robotic loader's got a big target to grab and a big target to hit. So we just don't have issues with the slide loader, which is quite nice. This slide basically goes through that you can run the system 24/7. It emails you when it's done, and you can top up the slide before going home by click and exchange trays. Barcode reader is built in, so you got the QR code, the data metrics, the EAN code. And the software is super simple. I'm not being salesy and trying to convince you here, ladies and gentlemen. It really is simple to teach. It's never taken more than an hour to show every feature of the scanner to people. That's just more software. So AI. So here's a little bit of the AI. It is neural networks, not machine learning. So it is the more advanced out of the two AI networks. And it's super simple to use. So I don't have a video of it, but this is a quick image showing pancreatic islet cells within liver. So you go in and you draw, you click and draw with the mouse, 1, 2, 3, and you draw around these islet cells and say, learn. So you give it about 50 to 100 samples, and it learns for you. Then it comes back and shows you what it's done. So here's an image with the probability map, what it thinks is positive, and then the final image on the right-hand side, where it starts picking up these islets. So why did we use this image? Well, look at this image. Look at the 3 positives in red here, these islet cells. Look at the image on the left-hand side. These pancreatic islets are yellow. You've got a lot of yellow red blood cells here, which are about the same size and about the same shape, but in fact, they're more intense. So if we just did an intensity threshold on this image, you're going to pick up these red blood cells first, but then it also smears. This image was used intentionally because it's quite difficult. You've got this kind of smearing right here. So the threshold will probably pick this up as well. Whereas these pancreatic islet cells here are dimmer, and it's definitely a challenging sample. But with the AI, it easily detected these pancreatic islet cells and picked them up. So there's actually 5. There's one here in the bottom left-hand corner. There's a large one here, 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 and one up in the top left-hand corner. So if you compare the final image to the one on the left, very, very challenging sample to detect. But the AI, and you've probably seen AI at this stage, it's getting very, very popular, very, very common, very easy to use, very accurate, and it's kind of fun to train as well. Data management, we have this net image server I was describing earlier on. You can log in using Windows, Mac, Android, Linux, which is not many people use Linux, but if you are, anything that has HTML5 access to the internet. This slide just basically shows you can access these image streaming and treat it like Netflix, right? You go in, you know the way Netflix has those little icons of all these different movies and shows you the front picture of the video. Likewise, it'll show you a little thumbnail of your image. So you can scroll through the folders and go, yeah, that's my image, that's what I want. Click on it and it pulls it open. It streams it to you in packets. So as you zoom in and zoom out, it streams only those packets in that area that you're looking at, but it's incredibly fast. You have Olivia, it's free, it's a free viewer. And then this is the last slide. The predecessor of the VS120 was successful. They've sold Olympus sold over 1,000 units worldwide. We hit triple global demand with the VS200 because it's so fast, with a larger slide capacity, and with the new XAP objectives with AI as well. So what people are doing right now are batch scanning whole projects and then using AI to batch analyze that entire folder And I was telling Paige before this talk, I did a presentation with Dr. Ron Chalkins that we'll send you a link to. And I give a presentation for 15 minutes. Ron is talking for about 35 minutes and showed the evolution of people going from manually staining glass slides, manually taking images and manually counting positives with the software, to upgrading to, he actually bought a Leica Bond, big auto stainer, those really, really cool ones. He's batch auto staining. Then he used an automatic microscope to scan 4 slides at a time, but then still he used like ImageJ or Fiji to scan a lot of these positives. And then the final stage of the evolution is using the Leica autostainer, an Olympus VS200, and Olympus artificial intelligence to batch scan entire photos of images. And he concluded by saying he reckons what would take 9 months several years ago, he's now doing in 4 days. And therefore he's just ripping through data. In fact, the slowest part of the entire lab is Ron trying to write the papers. But so that's a nice talk. We'll definitely share the link and definitely watch the talk. But so if you are on that stage and you're saying, hey, I'm working quite quickly at the moment, maybe there's room to grow. Maybe you can do batch analysis with artificial intelligence or batch scanning with this VS200 slide scanner. So I will, that's the end of the talk. Thank you very, very much. And I'm open to any questions.
Thanks for your talk, Gavin. I have a couple of questions, but I also want to leave it open in case anybody else has anything they want to ask. Let's see. Don't see anybody raise their hand or anything yet. Okay. Let's see. Oh, here's a question, I guess, in the chat. Is how many colors can you see with multiplex?
Yeah, so in one batch, the Olympus scanner can do 12 colors. So you could do 12, remove your slide, strip off your antibodies, do another 12, and overlay, and then scan it again. So you've got scan number 1 plus scan number 2. They overlay. They basically align it by the nuclei. And once it's overlaid, now you've got 12 plus 12 plus 24. So you can keep doing rounds of 12 until you max out the software. The software got a maximum channel of 64 channels.
All right. Any other questions? Anybody wants to put in the chat or you want to speak up? Right. I had a question where you were doing the basically kind of Z sections. I thought the insect images were really impressive. I was wondering what would be like a thickness restriction for that, you know, as far as like your clarity. You know, most of the time when people do histology, they're doing their 5-micron sections, but obviously, you know, like this insect was bigger, but maybe it was cleared or, you know, something to assist in its visibility that you could see throughout the insect when, you know, the image was merged.
Yeah, so it's still a wide field system. So you're going to run into issues if you've got like if someone brings down like a 50 micron H&E, you're not going to get through it. Yeah. You might be able to image it, but by the time you get to 50 microns, it's going to get blurry. So you run into, it's not a confocal. So you do run into the same limitations that you would with a normal imaging system. So, I mean, I've had people with 20, 30 micron sections in bright field and image quite well. I do know past that it gets funny. You can do 31 Z planes. So if you have a 60x objective and you're taking 0.4 microns, then I think that's 12 microns of tissue to get through. Then you've got to max out the 31 Z planes. If you have a 10x objective, 31 microns, or sorry, 31 Z planes at 10x can go up to about 100 microns in thickness. So it just depends on the sample. Now, if you've cleared tissue, if you go into fluorescence with clear tissue, you can probably max out those 31 Z planes and go in deep. So maybe you can start 40 microns deep and take 31 Z planes, maybe from 40 to 50 microns, and still get decent images. But any of the limitations that you've seen with clear tissue or with the wide field system, you're going to run into the exact same limitations with this system because it is just a wide field system. It's difficult to say. It is sample dependent. So that's definitely where we can find out during the demonstration. Bring your samples, let's image them, and let's see how deep we can go.
Okay. Let's see. You had thrown out different kinds of options or features, and I wasn't exactly sure, what would be included in a base system or, what is really upgraded, sort of thing.
Yeah.
So,
okay. Yeah. There's kind of 4 parameters. So it starts off a 6-light system, bright field only. You can upgrade that to include fluorescence. So a 6-light system with fluorescence. And then you can add in the robotic loader. So the robotic loader will change it from a 6-light system to a 210-light system. That's kind of the 3 tiers. You can do it in reverse. You can have a 6-light system with the robotic loader and then add fluorescence later.
What about also, you were talking like dark field. Is that something that's standard or, is phase standard, as far as your bright field contrast options?
Gotcha. Yes, what comes standard? So it comes standard with non-phase objectives because Olympus put the phase ring in the objective. So you either get the standard objective without phase or the objective with phase. So that's a decision you'll have to make at the start. You can always purchase them later on. You can still have a 20x objective and get a 20x phase later on if people do want phase. So phase does not come standard. What does come standard is 2x and 20x. If you get the fluorescence module, they add the 4x in by default as well. So 2420. The dark field actually comes built in. It's like $112. This little annulus that we drop into the condenser, and you've got dark field. As long as that cone of light is bigger than your objective NA. So really, you get dark field at it's perfect for 10x. It can work at the 4x, but the NA of the other objectives is too wide, and it sees that cone of light. It's meant to miss it. So you get dark field at 4x and 10x for free built in. I wouldn't say free. The cost of that is added into the system. But dark field is only a little annulus. It's only a metal disc. It's $112. So that comes with the system built in. Oh, and polarized light. Polarizers come with the system as well. So they're all motorized. They just swing in and swing out. Oh, and one last thing for polarized light. The rotation of your polarizer is motorized. So you can actually click the motor and get 1 degree super fine increments and leave it in that position. So you can really fine tune the degree of polarization, and therefore it's repeatable. So normally with polarizers, you put your hand in and rotate it yourself to get that exact fine tune of polarization. This time around, it's moving in 1 degree increments on a motor. And that will just move it out of the way or in the way, whether you want polarized or not. So polarized light comes standard as well. So polarized comes standard and dark field comes standard. You can add phase later on or add phase on the day into the quote. You can just say, no, I don't want these objectives, I want phase objectives, but we can just swap them out for you.
Okay, and then that EFI scanning, that's standard, stepping?
Correct.
Okay.
Yeah, EFI is just a software. It's built into the software. It's been around for Olympus for years. So you just have an option: scan in EFI or scan with one plane, or scan in virtual Z, which means you take the Z stacks and you can scroll up and down later, and you can flatten them down to an EFI later if you want. But that all comes standard within the software. So what does not come free with the software? Deconvolution. There's 2 deconvolutions. One is free, which is the Weiner filter. It does a decent job. But the one you pay for is about $9,000, and it does an outstanding job, particularly with very fine, small resolution, small features. That's at the edge of the resolution. Very, very dim features as well, low intensity. So you can pay for deconvolution. The fluorescent software module, you can pay for that as well. So if you just want bright field only and strip it down, you're not paying for things you're not going to use. It's not going to having a bright field microscope, but all the fluorescent software, right? Because you would have paid for that. So Olympus say, no, we'll give you the bright field module. And if you want fluorescence, you can add the fluorescence hardware and the fluorescent software as well. So it really is a la carte. You build up exactly what you need. Deconvolution is a pay module. The file sharing platform is a pay module. You can, of course, buy offline licenses. They're about, I think, $1,500 for an offline license. And that way you can get a lot of the modules built in for that for free. The analysis package, you can pay for it as well. Some people just use ImageJ. It's free, it does a great job. And ImageJ or Fiji reads the Olympus VSI format. There's a bioformats VSI plugin. So I always tell people, start off with the free stuff. Why spend money? And then later on you can add and build up if need
now
be.
when you're talking about image analysis, that would have been like that AI where you were recognizing the islets within the pancreas. So that
the AI is a pay module as well. Yeah. So the analysis package is pay. The next upgrade of analysis is the AI. You pay for that as well. And you pay for the deconvolution. So these are all modules that you can add on a la carte as needed.
And then back to the illumination, I assume there's standard in that if you start using or wanting the extended wavelength into the IR, then that's, you know, like an upgrade sort of thing.
Yeah. So the base model is the Xylus, which is a white light. It's a, I'm going to skip to it. Oh, it's a white light LED, and that goes up to size 7. But if you want to go, if you know from day one that you're like, look, we do use IR 800, we use Opal dye 790, use Alexa Floor 800. Then on the quote, what we do is we start off by putting in this as the only light source instead of putting in the first one, the Xylus.
So now if you do extend that wavelength, then you have more base level channels that you can detect. Is that?
Yeah, it opens it up into like, for example, the Xylus cannot do, it does Alexa Floor 750, it won't do Alexa Floor 800. So, and it doesn't do it doesn't really do the Opal 790, just can't really excite it well. But this one will give you literally 1 extra channel, I believe, over the Xylus. But the difference is as well, the Xylus is a white light source. All the LEDs come on simultaneously and off simultaneously. Whereas the Novum, you have an extra LED out here at the far red at 800, but each LED can be turned on and off on its own. So if you put in a Pinkel set, if you put in a multi-band filter set, then you've got no moving parts. You just have the LED flickering, dappy fitsy tritsy super fast, and you've no moving parts. So it's going to be faster than getting this white light source with maybe filter wheels.
Okay. I'm assuming that oil dispenser is an upgrade too, right? The oil dispenser?
Correct, yes.
Okay.
Yeah, so if you, I mean, some people say, I don't want an oil dispenser. How much is that? It's like, well, the oil dispenser is $9,000. It's a pump, it's a beam, it's got the software, it's all built in and integrated. And so if we sell somebody a bright field only system with an oil dispenser in there, but they've no oil objective, it'd be pretty fair to open the door and say, hey, listen, I've paid for that, I can't use it. That's $9,000. So Olympus have built everything a la carte. So if you do get an oil objective, you can buy the oil dispenser, and it's field upgradable as well. So if you don't think you need oil, don't buy it. But if a year down the line, you're like, hey, Gavin, we've had 12 requests for oil. We're going to buy the oil and get an upgrade. We don't have to ship this back to head office to get upgraded. Either I fly in or a technician flies in and installs the oil dispenser for you, and then screws in the new oil objective lens.
Okay. And then one other question is, I know the Visio Farm Group were recommending, your system and all that, but at what point would you say that you should look at a more advanced analysis software like that, as opposed to what like you guys offer as, an upgrade for AI or image analysis?
Yeah, so before the Olympus image analysis package is very, very similar to Fiji, where you've got a lot of different pattern recognition filters, size, shape, sphericity, maybe orientation, is it north, south, or east, west. But it doesn't do more advanced things like clustering, where you go in and say, hey, I want to know if this pathology is changing. Like, yes, we've got some positives, but are they clustering together or are they moving and spreading further apart? Because that may be quite significant. So going into much more advanced questions like, is this treatment working? Is it not? Rather than just pattern recognition, like, hey, count all the positive cells, count the big round ones versus the small elongated ones. That's very, very simple, just standard pattern recognition. But getting into more of the advanced, like, for example, cell membranes. Visiopharm is incredibly powerful. It's got one of those apps that has cell membranes. It only detects the edge of the cell membrane and whether or not it's continuous. Are these cells touching and all expressing on the membrane? A lot of pattern recognition softwares may be able to recognize a honeycomb shape because it's got holes. Search for one hole. But Visiopharm can say, this is actual membrane because it's associated with a cell. It's right beside a nucleus. So that type of histological train of thought, that really is the dividing line of like, oh, we just have simple pattern recognition, or we need histological analysis and get into much more advanced thinking of whether this is a disease progression or a regression, or maybe the treatment ameliorates this immunological response. It's a good question. I know exactly where the delineation is, only because I've seen so many examples of whether to go with the analysis package or Visiopharm or Halo or whatever you have. It's difficult for me to describe because the lines are beginning to get blurred because Olympus brought out AI.
Yeah.
And the AI now can pick up a lot of different things that normal pattern recognition software couldn't. So,
well, and yours is more of an automated where you can add definitions, but you don't have to code, where I think Visiopharm is very much coding, right?
Yes, the Olympus software is very, very simple to use. It really is. Just like ImageJ or Fiji, where you've got little sliders and you move the slider and suddenly on the image it picks up more populations. And then the AI is drawing. You draw. I've got a stylus right here on my laptop. And I pull this out and I can just click a button like a mouse and I can draw my cells. And just once and the drawing tool for the AI is quite easy. You got different fonts, you got delete button, and you just draw about 50 to 100 samples. And then you draw background and say, okay, this is background, label as background, and say, now go learn. And it goes ahead and learns for you. So you just need a bit of time, sit down with a cup of tea or coffee and just draw. And the more accurate you draw, the better of a job it does.
Okay. Let's see. I think that's pretty much the questions I have. And like I said, we're looking at the first week of November to set up a demo?
No, November 15th, I've scheduled the unit for you. Yeah, yeah, so bring slides. So I normally book people in for 2 to 3 hours. And I say, look, bring your slides, whether they're bright field, picker series red, whether they are H&Es, immunofluorescence, immunohistochemistry, cleared tissue. So what can't it do? If you have something like 500 micron tissue and you want to scan whole 500 microns, we may not have an objective lens with that working distance, right? That may be more of a laser scanning confocal. But if you've got normal thin tissues up to maybe 50, 100 microns, and you want to take, and you've been able to image them in wide field before, then great, we can do the same. The whole goal here is volume. So here's one reason, or here's one good example of the slide scanner. People try and say, yeah, it would be cool to scan 80 slides in one go, but we can kind of do that in small batches on our existing microscope, because our existing microscope can do batches of like 2 to 4 slides. So we kind of have a mini pseudo slide scanner at the moment. So I would say, okay, do you scan at 40x? Like, oh no, not 40. It takes way too long. It's like, would you like to scan at 40? They're like, yeah, we'd love to scan at 40. The Olympus scanner is so fast that now you can scan at 40x, probably faster or the same speed as your motorized microscope can scan at 10 or 20. So it opens the door to another layer of resolution that you didn't have access to before. And it's not that you didn't have access to it before because you didn't have the equipment, you just didn't have the time to scan and hog your microscope and block up your microscope for a day or two. So that's another That's another reason to get a slide scanner, or sorry, not a reason to get one. It's one of the benefits of having a slide scanner, that you can scan a higher resolution. I've had many people say, oh, just scan at 10x. I'm like, okay, I'll do that, but do you mind if I scan at 20 or 40? And they're like, yeah, sure. So we scan at 20 or 40 and they turn and go, oh my God, I can see my biology. I can see my sample. That's important to me. Normally I do small little scans at 40x, but you're scanning everything at 40. Hold on a minute, this is new. Now I can start thinking different. Now I can analyze the entire thing at much higher resolution. And we've had a lot of feedback by that, by me scanning, or by the scanner scanning at a higher objective lens. And therefore now people have access to that higher degree of resolution.
Okay, I mean, I'm excited for the demo, and we do have some histological slides, and so we'll definitely be bringing them, and hopefully some of the people that were in attendance, they also have histology that they work with within their lab that they'll be bringing. But yeah, definitely want to get the dates down, specifically, and what the time frames, which people should sign to reserve time slots and that kind of thing, so we can get that, going and be prepared for that when the time comes. So.
Yeah, normally we have 18 slots. Sorry.
Okay.
Within
a week.
9 slots. Yeah, within a week.
9. Okay.
And so the last demo I did in Utah, there was 14 slots, 14 groups in 9 slots. So a lot of them were double booked.
Yeah.
It actually worked really well, because what happened is people came in and one person would sit down and go, hold on, what sample do you have? They're like, oh, you're asking to do this scanner way more advanced than my slide. My slide is simple. I'm not going to scan my slide. Let's scan this person's slide. And now both people talk to each other, and they end up meeting other researchers and see what other people do. So it actually worked out for the better. So even if we have 2 or 3 groups in the room at the same time, it's still fine, because you still get to see somebody else's slide being scanned, or maybe your slide being scanned. I usually choose the one that's more challenging, and then people can learn. A lot of people say, oh, you know what, I never thought about that, but I'm watching this other person's slide being scanned. That has opened up a couple of projects that I now am thinking of that normally would have had to say no to. But now we can do it because the scanner is here and we can do this. So it's usually very, very interesting. The demonstration is usually a lot of fun.
Okay. So any other questions from those that are still on the line? I don't think so. Well, thank you very much for coming and talking to us, and we're looking forward, of course, to the demo coming up in the week of November 15th. So
and there's one more question here from Carlo. Will we be able to scan slides with fluorescent stainings? Yes. So I'm going to bring a full complement of cubes, different mirror cubes. And so yes, fluorescence, bright field, dark field. The only thing I don't do is phase contrast during the demonstration. I just got to change all the objective lenses. So if you're doing phase, we can do phase. I just don't bring the objectives. Most people don't want phase. That's why we just have the standard X-apo objective. So yes, bring your fluorescent slides, bring your bright field slides, immunofluorescence, immunohistochemistry, in situ hybridization, whatever you have. If it's on a glass slide, please bring it along. We'll scan it for you.
All right. And make sure we let everybody know about that. Any other questions?
And I have a pre-written email of an invitation page that I can send you, and it just says this is what's coming. They can scan in these different wavelengths, and please bring your slides. I'll kind of cut and paste it, send it off to you.
Yeah, sure. Then we can send that out, and then I wasn't sure if you sometimes the vendor has the sign up online and stuff like that. We'll organize it, and other times we'll do it. So I wasn't sure what your preference was on that.
You know what? I've been hit with some of these programs, Doodle and a couple of others, and it's been hit and miss. I don't like misses. It's not good. Do you have a sign-up sheet that you already have software for?
I mean, we can easily generate something, so either way is fine.
Yeah.
So
I can talk to you offline about that. We can arrange it. We can get something done.
okay, yeah, no, that's
Okay.
fine. All right, okay, well, thank you again for coming and talk to us, and
You're very welcome. Thank you for the invite.